Now, the A, B, and C here don't really matter there. So you should have done simultaneous equations with two variables before. So something like that. If I had x plus y is equal to 6 and 2x plus y is equal to 1, something like that. So you should be able to solve them already. So if you're not able to do them already, then you should go back and learn them first. But these are more complicated then. They've got three variables in them. So we've got an x, a y, and a z. We're just going to get rid of the a, b, c. They don't really matter. Now I'm just going to take the first two first, and write them out. So x plus y plus z is equal to 6, and 2x plus y minus z is equal to 1. And we're just going to make the z's cancel out. Now for this one, I don't have to multiply either equation by anything, because we have a minus z and a plus z there like that, so they'll cancel out without having to do anything to either equation. That won't always happen. Therefore, if I just cross those two out and I add downwards, so we have 3x plus 2y is equal to 6 plus 1 is 7. Then I'm going to go back and I'm going to take the bottom two equations now. So I'm taking the second equation and the third equation, and I'm going to do exactly the same thing with them. I'm going to make the z's cancel out. Now you could take a different letter first if you want, but I always just make the z's cancel out. It's probably going to be the same amount of work no matter which one you choose. Now, because we have a minus z or minus 1z and a 2z there, we need to multiply the top equation by 2. And if we multiply that by 2, then we'll have minus 2z on top and 2z on the bottom, and then they'll cancel out. That's going to be my first step here. It's not as simple as the other one, but it's not too bad either. I just have to multiply everything by 2. I'm going to get 4x plus 2y minus 2z is equal to 2 times 1 is 2. And the bottom line, 4x minus 3y, I'm not doing anything to the bottom line, just writing it out again, plus 2z is equal to 4. Now the z's, I put a line through them and I'm adding downwards then, so 8x minus y is equal to 6, and therefore I've got two equations now with x and y in them. So I'm going to take both of those equations and I'm going to write them out fresh. 3x plus 2y is equal to 7, and 8x minus y is equal to 6. And now because we've got two variables, we can go ahead and solve them and figure out what x and y are. Again, I need to make either the x's or the y's cancel out. I'm going to multiply the bottom equation here by 2, and that'll make the y's cancel out. Therefore, I'm getting 3x plus 2y is equal to 7. I'm not doing anything with the top. And the bottom will become 16x minus 2y is equal to 12. They'll cancel out. Next, I'm just adding downwards again, so 19x is equal to 19. And I can divide across then by 19, so x will be equal to 19 divided by 19, which is 1. So I've worked out that x is 1. So I've got one of the variables figured out. I still need to figure out what y and z are. I'm going to take the 1 and I'm going to put it back in instead of the top into the top equation here, because that's an equation with just x and y in it. So if I put in something for x there, I've only got one variable. I can figure out what y is. Then 3x plus 2y is equal to 7. Put in the 1 instead of the x. 3 plus 2y is equal to 7. I can bring the 3 across and divide and subtract it. So 2y is equal to 7 minus 3, which is 4. And then y is equal to 4 divided by 2, which is 2. Now I've got x and I've got y worked out, and all I need to do is figure out what z is. If you look here, then we need to take an equation that has x, y and z in it, and we can put in what x and y are. If you look at the first equation, the x plus y plus z is equal to 6, that's probably the easiest equation to sub back into. You can sub back into any of them though at the top. Now x is 1, so I put in a 1, y is 2, and I leave the z in is equal to 6. Therefore 3 plus z is equal to 6. I can bring the 3 across, and it is equal to 3. Now I've worked out what x, y and z is, so I'm finished. Now you can go back and you can sub them in again into some of the other equations and double check them if you want, but that's essentially it. Now there is a lot of working out involved in it, and it takes a lot of space up, but it gets quite repetitive when you do a few of them. So here's another question then. If you want to pause the video and try it yourself, you can. I'll play it on and I'll go through the answers. Again, we're going to take the first two equations here, and I'm writing them out. So 2x plus y plus z is equal to 8, and 5x minus 3y plus 2z is equal to 3. I put a line under them. Now I'm going to multiply the top equation by 2. Well, I'm going to multiply it by minus 2 to make them cancel out. Therefore I'm going to get minus 4x minus 2y minus 2z is equal to minus 16. And the bottom equation says the same, 5x minus 3y plus 2z is equal to 3. I have it now where I have a minus 2z and a 2z. I like to make one a minus, and then we can just add it. So you could do it a different way if you wanted. I'm going to get x here. I'm going to get minus 5y here. The z's are gone, and it's going to be minus 13. Now let's take the bottom two equations. 5x minus 3y plus 2z is equal to 3, and 7x plus y plus 3z is equal to 20. Now this is quite awkward because I have a 2z and a 3z. We want to get the z's away because we did the same in the other one. What I'm going to do is I'm going to multiply the top one by minus 3, and I'm going to multiply the bottom one by 2. Therefore that'll make that 2z into a minus 6z, and it'll make this into a positive 6z. Therefore they'll cancel out. Then just be careful with the multiplying. I'm going to get minus 15x plus 9y minus 6z is equal to minus 9. And the bottom 14x plus 2y plus 6z is equal to 40. 2 times 20 is 40. Now I'm going to get minus x plus 11y. The z's will cancel out and is equal to 31. Then I've got two equations with x and y in them, and when I have that I can put them together and solve for x and y. X minus 5y is equal to minus 13. I'm going to use a different colour pen now just to help see the difference in what I'm doing. It's not for any real reason. Now here the x's actually already cancel out, so I'm going to get rid of the x's next. We can do that. We don't have to go to the y's next. You could if you want. 11y take away 5y is 6y, and that gives me 18. Therefore if I divide by 6 I get y is equal to 3, because 3 6s are 18. Then I'm going to take the top equation, I'm going to take this one here, and I'm going to write that out again and put the y in for it. So x minus y is equal to minus 13. X minus 5 times 3 is equal to minus 13. X minus 15 is equal to minus 13. And if I bring the minus 15 across and add it, I get x equal to 2. Therefore x is equal to 2, y is equal to 3. I've only got one variable left to figure out. Let's go back up to the top and get an equation with x, y and z. So I can take any of the top ones there. I'm just going to take the first one, 2x plus y plus z is equal to 8. And I'm going to put a 2 in, so 2 times 2 plus y, we know y is 3. So plus 3 plus z is equal to 8. 2 times 2 is 4, plus 3 plus z is equal to 8. 4 plus 3 is 7, plus z is equal to 8. And I can bring across the 7 and subtract it, and we get z is equal to 1. And I have x, y and z again. We could sub them back in now into the equations if we want, but that's it. So there's a lot of writing out and working out in this, but it's pretty much the same steps all the time and does get repetitive. It's just a matter of practicing it.